Welcome back. It's Local Edition. I'm Brad Pomerantz. Thanks for joining us again. Our guest is Mary Droser. She is a professor at UC Riverside. She's a paleontologist, but lately she's been focused on climate change and climate science. I want to very quickly ask you about climate change. Pretty controversial. What does the scientific community believe about climate change?
Well, the scientific community overall, 90% of all scientists working in the climate change research area overall, clearly understand that climate change is occurring and that the data support this.
And does that data say that it's occurring as a matter of cycle or human behavior?
It's anthropogenic. Which means as a result of human behavior. And the thing is as scientists, we understand natural climate change. We understand the rate and scale of natural climate change, and that does happen, and it is happening. But the rate of climate change right now is orders of magnitude greater than we can in any way come up with from any natural causes.
And that's what you're teaching students at UCR.
That's right.
And high school students as well in the region as a result of a NASA grant.
Right.
Tell us about it.
So one of the problems with climate change and the issues surrounding climate change is that there's a disjunct between what scientists think is going on and what the public believe.
Right.
And so given whatever poll, it's about 50% of the public don't believe in climate change. And the question is, well, why don't you believe in climate change? And why is climate change science or climate science different from any other science? We use science all the time. We use science in the cameras that are filming us right now. You go to the doctors and we use medical science all the time when you start your car. So science is every part of our day-to-day, and it is something we live with and we trust, and we don't question, do I believe it or not? We just use it in our day-to-day lives. So why is there a disjunct here? And I think that there are a number of reasons. One, the implications of climate change are really scary.
They are scary.
And we don't want that. And unlike earthquakes, when you live in Southern California, you can't be an earthquake denier because we feel them. We understand they happen. But climate change, you're like, well, it feels cold out today. Nah, so no global warming,
right? It's more of a rainy season than last year.
Absolutely. DC had one of the worst winters on record last year. Okay, so no climate change. Easy, done, don't have to worry about. And the problem is that climate change happens over the time scale is different. Weather is day to day. Climate is 20, 30-year patterns.
But what you're teaching the students is we see that sea levels are dropping, we see the polar ice caps are melting, we see that temperatures are increasing year by year. Is that accurate?
Right, yes, but what we want the students to do is see that for themselves. So I can get up there and lecture all I want about climate change, and you could be one of my students, and halfway through you'd be tweeting and doing this. No, you wouldn't, but others might, right? And you'd walk away, and later your neighbor would ask you about climate change, and you'd think, well, I know I learned something, but I'm not sure.
So what do you do with the students?
So what we do with the students is we use the wealth of NASA data. And NASA has nearly 50 years of climate data, remote sensing from satellites. So you can find a point on the coast of California and get ocean temperatures for the last 40 years.
I have to think that the students' eyes just open so widely when they see the maps, the images from space, the data.
Right, and they themselves then use these data. So we develop modules. And so instead of me lecturing, I would say, Brad, sit here with me and let me show you how to do it. And you would sit and you would say, all right, I want to look at ocean temperature off Laguna for the last 20 years. And I want to look at, what does CO2 look like over the last 20 years? And when you start...
You can see the whole.
You start, that's right, you start to put that data together, and then you can say, all right, if this trend continues, what's going to happen to sea level? What's going to happen? So if it's hands-on, and we're not just aiming for science majors.
You have to come back and talk more about it. I'm fascinated by it. Mary, thanks for joining us. I'm Brad Pomerantz. Thank you. Back to HL.